Today I will introduce the following content. First, what databases are, then two types of data models and their comparison, then two types of deployment options and comparison. I will also introduce two AWS database services, AWS RDS and AWS DynamoDB. I will also introduce a recommendation for how the company might use each service. Databases are organized collections of data that can be stored and accessed electronically. It has the following data functions. It allows data to be stored and managed in an efficient and structured way. It helps perform various types of data analysis. It helps protect data from unauthorized access, modification, or deletion. It helps ensure data quality and consistency by enforcing rules, constraints, and validations on the data. Relational and non-relational database are two types of data models that define how the data is organized and accessed. Relational database has tabular data model with rows and columns. It has fixed and predefined schema. It has SQL query language, and it has high data integrity and vertical scalability. It is good for complex queries and joins. It is used for structured and consistent data such as financial, inventory, and customer data. Non-relational database has various data models such as key value, document, and graph. It has flexible and dynamic schema. It uses a non-circle query language. It has variable data integrity depending on the type and configuration. It has a horizontal scalability. It is good for simple queries and high throughput. It is used for unstructured or rapidly changing data such as social media and web content. Now I will introduce the two types of deployment options, cloud-based and on-premises. Cloud-based and on-premises solutions are two types of deployment options that define where the data is stored and how it is accessed. Cloud-based solutions store data on remote server managed by a cloud service provider such as AWS. On-premises solutions store data on local service managed by the company itself. Now I will introduce the comparison of a cloud-based solution architecture using AWS as an example and on-premises. Cloud-based solution architecture has benefits over on-premises in cost efficiency, security, scalability, accessibility, maintenance, and innovation and speed. For cost and potential savings, using Amazon Database Service can help you reduce the cost and complexity of managing your own relational database on premises. You can pay only for the resources you use, such as the DB instance class, storage type, and backup rotation period. You can also save on the hardware, software, and maintenance cost associated with running your own data centers. You can also optimize your cost and performance by using features such as auto-scaling, provisioned IOPS, and reserved instance. For security concerns, using Amazon Database Service can help you enhance the security of your data and comply with various standards and regulations. You can use encryption and AWS KMS to protect your data at rest and in transit. You can also use IAM, VPC, and security groups to control access to your DB instance and data. You can also use backup and restore snapshots and multiple AZ deployments to ensure data availability and durability. You can also use CloudWatch and Performance Insights to monitor and troubleshoot your DB instance. Overall, using Amazon DB service can help you enjoy the benefits. You can easily scale your DB instance up or down, or use RAID replicas to handle RAID-heavy workloads. You can also choose from various SQL engines. Now we will introduce AWS relational and non-relational database service. They are all cloud-based solution architecture. Amazon RDS is a service that allows you to create and manage a relational database in the cloud. You can choose from various SQL engines such as MySQL, PostgreSQL, Oracle, and SQL Server, and use SQL commands to store and query your data. Amazon RDS offers features such as scalability, performance, simplicity, backup and recovery, availability, monitoring, and security. Amazon DynamoDB is a service that allows you to create and manage non-relational database in the cloud. You can use Amazon DynamoDB features such as auto-scaling, in-memory caching, backup, and restore, streaming, and transaction to enhance the functionality and performance of your tables. Now I will introduce how the company might use Amazon RDS. Using Amazon RDS to store and manage a product catalog, customer information, order history, and payment details for online marketing, marketplace, and website. In the above scenario, Amazon RDS is used to store and analyze some of the transformed data that is generated by a cluster of Amazon EC2 instance. Amazon EC2 instance allows you to launch and run visual server in the cloud. You can use Amazon EC2 to perform data transformation tasks such as cleaning, filtering. The original data is uploaded to an Amazon S3 bucket by the users. You can use Amazon S3 to store the raw data that needs to be transformed. The transformed data is then stored in a different Amazon S3 bucket by the Amazon EC2 instance. However, some of the transformed data is also inserted into an Amazon RDS instance, which is labeled data store. This Amazon RDS instance can then be queried by using analytic software or an Amazon Analytics service that can make circle queries to access the data for business insights. For example, you can use Amazon QuickSight, a service that allows you to create and share interactive data dashboards and reports to visualize and analyze the data stored in the Amazon RDS instance. You can use Amazon QuickSight to connect to the Amazon RDS instance and run circle query to explore the data and discover patterns, trends, and outliers. Amazon DynamoDB can be used to store and manage the user preference, shopping carts, recommendations, and ratings for the online marketplace and website. These types of data are unstructured or rapidly changing and require high performance, low latency, and flexible storage and query. Then I will introduce how the company might use Amazon DynamoDB during migration. The migration progress begins with identifying the table in the source table database that will be migrated to DynamoDB, utilizing tools like AWS SCT for analyze. Corresponding tables are then created in DynamoDB with a similar key structure and data model using various AWS services such as the Management Console, CLI, SDKs, or Amplify framework. A replication server is set up in AWS DMS to facilitate the migration process with source and target endpoints configured. Pre-roll transformation are defined if necessary using AWS SCT to generate transformation rules applied to the AWS DMS task. the AWS DMS task is started and the progress is monitored using AWS Management Console, CLI, SDKs, or CloudWatch. Data quality and integrity are validated after migration, comparing data in the source and target tables using AWS SCT. Finally, applications are switched to using DynamoDB tables instead of the source database tables with AWS SDK, CLI, or Amazon API Gateway for RESTful APIs. After migration, to use Amazon DynamoDB to sell crafts online and enable individuals to set up their own storefronts and sell their crafts on the website. First, we should design your data model and schema for your DynamoDB tables. You can use various data models such as key value and document, and use non-circuit commands to store and query your data. You can also use primary keys, secondary index, and stream to optimize your data access and performance. Then you can load your data into your DynamoDB tables. You can use the AWS SDKs or AWS CLI to load data into your tables. You can also use AWS Data Pipeline, AWS Database Migration Service, or AWS Glue to transfer data from other source to your table. Then you should implement your business logic and user interface for your online marketplace and website. You can use the AWS SDKs or AWS CLI to query data from your table. You can also use AWS Amazon API Gateway to create RESTful APIs to access your data from the web or mobile applications. You can also use AWS Lambda, AWS 3, and other AWS service to build and deploy scalable and serverless application. Finally, you can test and optimize your online marketplace and website. You can use AWS X-Rays, AWS CloudFormation to monitor and troubleshoot your applications. You can also use AWS Autoscaling, AWS CloudFront to improve your scalability, performance, and availability. That's all for my presentation.